For our next session, I invite Mr. Mohammad Umair Khan, an active member of GDG Kolachi, Angular, Pakistan, and community lead for Docker Karachi, to present his session on Docker for front-end developers.
All right, so I'm Mohammad Umair. In case you missed, I am from Pakistan, and I work at this amazing company called 10 Pearls. There's this dev shop based out of US. We do a lot of different projects for companies from all over the globe. I do some community stuff. GDG Kolachi is the local developer groups for Google. I'm also a member of Angular Pakistan, and I do lead this community called Docker Karachi. Right. So I will be talking something you might not have heard of. People who are working actively in software companies might have come across this word. Sometimes people say it's related to DevOps, infrastructure engineers, but I think it's related to all software engineers. And it's specifically, we're going to talk about a front-end perspective of containers. So I'll start off with a small story of how I got interested into Docker and then containers and so on. So we were doing this big project for a big company in the US. NDA calls, I cannot name it, but it was one of those companies whom you'd send an email out and it would wreak havoc in the entire upper layer of my organization, right? So it was a big client, and we were working for them for a management system, which comprised of Angular, and then they had .NET, yes, ASP.NET, web services and the backend, and then it was backed by the SQL Server. So one of the backend guys, I was the lead on the Angular team. We did great stuff on micro front ends back a few years. People are talking about it right now, but we built them at least 3 years ago with Angular 2 beta and all that. Great. So the backend guys, what they did was their API was sluggish, and they made some changes and introduced a caching layer in all the APIs. And what happened was, once you hit out the API, we are all front-end developers. We just hook in the URL given from the backend guys, and we just call in from the data from the APIs. So they pushed a caching layer on the APIs and gave it to us and said, hey, just take it. Your APIs are a lot faster now. Okay, we went on, we integrated the APIs. It was successful on our dev machines. And then we pushed it onto the other environment. It was the QA environment where the testers would go and say, okay, you've missed that, you've missed that. Everybody hates testers. But it's good to have them, and they're there for a reason. So the testers went there, they did not spot in any issue, and then we pushed to staging. Staging was based on Azure. It was a distributed environment. The entire thing failed. And why did it fail? Because the caching API that they used was in memory. And when you go onto a distributed environment, things get distributed. You have multiple instances, multiple processes, multiple deployments running on each backend server. And eventually what happened was, my first API, everything was under a load balancer, right? A load balancer is something that balances your request, gives you an endpoint to hit to. So we were hitting the load balancer, and one request would go to server A, it would create a cache there, and the subsequent request would go to server B, and there would be no cache. So everything actually broke down. So then we thought of this, that there has to be a better way in which I can look into these problems beforehand. So that's when I discovered Docker. That's when I discovered containers. And that's when I realized that you can do this actually before going into production. So you can create the exact replica of the production environment on your developer machines. And it would be super lightweight. You would not feel that it's too much to handle, it's a few simple commands. We look through it. So we went on, we did this another amazing project, an MVP for a company in the US. It was using Node.js, again, Angular on the front end, and then it had a fancy database. You might not have heard about it. It's a multi-model database which can store SQL and NoSQL data. It's by the name of OrientDB. We were using a clustered, multi-layered setup of the OrientDB. And what eventually we did, we were able to emulate all that stuff with containers, right? So this is how I got interested. So the problems that we identified are, it works on my machine, right? Everybody says that it works on my machine. You go to the testers say, hey, this is the issue. And you say, no, it's working on my machine, right? There's an issue on staging. It's working fine for me. So this is one of the problems. If they're saying something, listen to them. They don't have anything personal against you. They're there for a reason. And the other thing is, will it work on production? So this is the flip side of the same question, that will it work on production? So if I introduce a change, would it sustain in the type of production environment or staging environment I have? Or would it actually fall out? So Docker is a container platform that provides APIs to create and manage containers, its images, and all that stuff. So how many of you have heard of containers? Right? Quite few of them. That's very good. And how many of you only heard it after Docker? So you guys knew containers before? That's amazing. Containers are something that's native to Linux, and you can create and manage them via LXC. So that's not something that's groundbreakingly new. That's there in Linux already. Docker provides a bunch of APIs that you can use and make it easy for everyone, all the software developers, all the DevOps folks to use. So how we talked about you can emulate the entire environment, your setup, your production setup, your staging setup on your machines. If you look at it, that would be pretty heavy. But that's not the case with Docker. So everybody is provisioned an Azure VM, right? Almost all of them. Or some people have maybe provisioned a VM on AWS. So virtual machines are actually designed in which there's a hardware layer, there's an infrastructure layer, and then there's a hypervisor. This hypervisor goes on and virtualizes all your hardware and then breaks it into each one of them on which you can install an operating system. And that operating system is going to have its standard libraries on it, and then there's going to be your application code over it. So there's 2 to 3 layers of stuff that's going in the virtual machines. If you look at how containers behave or how Docker behaves, is there's an infrastructure layer and there's only one host operating system. And then there's a Docker daemon running over it, and that daemon shares the entire standard library for the operating systems with each of the containers, so you don't have to repeat them. So there's less redundancy. So that's why containers are very lightweight. If you think of this as containers versus virtual machines, that might be incorrect. They're used in tandem. They're used together. So first you create a virtual machine, and then to create multiple containers on it, it's fairly easier and fairly lightweight rather than creating many virtual machines. So look at it and in this way rather than comparing them one-to-one. Right. So before we jump into some further details for Docker, I want to go back to the basics, and everyone can identify what is this, right? This is a class, a simple class. It has a constructor function. It takes a couple of fields, and then it initializes them once you create the constructor function. And then you have a simple method by the name full name, and then it concatenates the two. Nothing fancy about it, right? And then this is just a blueprint, and this is nothing more than a blueprint. There is no physical existence in memory other than a blueprint that we can use to create more such objects. So if we move on, we can create an object by the name of Batman, and then we can give it the first name and last name Bruce Wayne. That's fine, right? We use the first person class, and then we created a new object out of it, right? And this new keyword, what it's going to do, it's going to create the object in memory, give it physical existence, and give it an address, and now you can access and play around with it. Similar is with Robin, right? Dick Grayson is one of the characters that played Robin. So we can use the same person class, no need to create it again and again. Very similar to this concept are Docker images and Docker containers. Images are actually blueprints which contain layered instructions on how a container would be created, right? And a container is basically an instance, a nude instance of that running as an image, right? You call Docker run on an image, it creates a container similar to you call new on a class and it creates a class instance. This is how it's as simple as this is. And all these images are stored into a registry known as the Docker registry. And Docker registry is very similar to Docker GitHub. On GitHub, you go ahead and store your source code. On Docker Hub or other Docker registries, you simply go there and store Docker images. So we'll go and see this one by one by running the commands. You can pull the Docker images from the registry, similar to how you pull your code from GitHub, and then you can do a Docker run and have multiple instances of the same container running. So let's go ahead and let's do some live code, right? I just want to make sure that I zoom in as much as I can so you guys can see it. Right? That's visible. Can I somehow turn this off and turn on this one? This was on, right? You guys can hear me? Great. So I want to first take everyone to something known as hub.docker.com, right? So this is very similar to how GitHub works. And hub.docker.com is going to host all the Docker images. This is for Nginx. How many of you have heard of what Nginx is? Nginx is a web server. Somehow down the road, you're not going to be using ngserve, and then you're going to putting your code into either Nginx or Apache Tomcat or IIS or any other web server, right? So this is the page that would give us all the information that we need to know about Nginx images. So it has a bunch of tags. Tags are similar to Git tags. If you have used Git tags, these are very similar to that. They define the versions that you push on Docker Hub, and you get a quick reference of how to use this image and all that stuff. So on the right side that you can see is, let me zoom in. On the right side, you can see is Docker pull nginx, right? So what this would do is it would go ahead and pull the image on your machine. So I'll say Docker pull nginx. I can give it any label, any tag that I want to. If I don't mention anything, that's going to get the latest. So I'm going to press enter and see what happens. It's pulling in. We talked about images having layered commands. They're all layered over one another so that they can be cached whenever possible. All right, so this is going to take some time. So I'm going to skip this, or else I'll just move to a new tab, and I'll show you. There's some images that are already there. There you go. Zoom out a little bit. Right. So when we pull Docker images, you can simply run the Docker images command, and you can see the bunch of images that are already there on your machine. So I already have Nginx Alpine. Alpine is a very minimal distribution of Linux, only a couple of megabytes, I think 5 megabytes for the entire operating system. It's ideal for a lot of production stuff. You can just put in what you need from the system libraries, and then that's it. You won't get a bloated Ubuntu or Debian or anything else. So Alpine is the minimal and what you should always use. Great. So I already have an Nginx Alpine, and what I'm going to do is I am going to try and run this. I have already pulled this on my machine, and I am going to try and run this. So the way to do that is simply doing docker run, and then I'm going to attach a flag called detach, right? And what detach is going to do, it's going to free up your command line. Otherwise, it would hold it until you cancel it or you exit the container. So detach is going to give the command line away right away. And the other thing that I'm going to do is add a publish. So what publish is going to do is it's going to transfer all the data from within the container to my host machine via a port. Right. So if your container, if your image exports data out of a port, that generally happens when you have web servers, and it gives you all the data from port 80, right? So you need to map that onto your host machine so you can access that. So let me show you that right now on localhost 8080, we have nothing running, right? There's nothing running on this port, and I am going to publish 8080 to 80. So this is the way Docker understands stuff. So I'm telling it to publish whatever is published from within inside the container at port 80, map it to port 8080 on my machine. As simple as it gets. And I'm going to give it the name Nginx Alpine, and I'm going to run it. So it gives me a hash in return. That hash is the identifier for the container that's running in. So if I do a docker ps, all these commands are available on the cheat sheet. You don't need to learn them. Just try and understand how the entire thing is working. So if you do a docker ps, it gives you that, okay, this container for image Nginx Alpine is running for the past 8 seconds, and it's mapping 8080 to 80 on the TCP. So let's go ahead and refresh it. And voila, we have the Nginx running on our machine. So how easy was it running Nginx as opposed to installing something, pressing next infinite amount of time, doing an accept on the service agreements and all that? That's fine. You should do that, but it's super easy to do these things with Docker. Right. Let's move forward. So what else can I do with Docker? We're here at the Angular conference, so let's try and run an Angular application inside Docker, right? So let's do that. I am going to go to, all right, and I already have created a Docker app. Let's try and do an ngserve. And see if that's working, right? So let's go and great. So this app is working fine. So if you like I said earlier, you're not going to use ngsrilanka for production applications or anywhere else. So you have to put it inside a web server. So let's try and do that. We'll do an ng build. Right. So we have the entire thing built here. we can see all the files are created. So let's go ahead and run this app inside a container. And the easiest way to do that is you do, first let's stop what's running already. So let's do a docker stop, and you can just use the first one or two characters from the container ID. It does identify that. So do you do docker, and that's it. And you do a docker run, you do a detach again, you do a publish again, and now we're going to add another flag, something known as volume. And what volume is going to do, it's going to share the files from your host machine all the way inside the container, right? So it's gonna map and create a link between the two. So let's do that. So I want to, pwd is the current directory path, and I want to do dist / docker -app into let's have a look what's the path for Nginx. So as simple as, there you go, usr share Nginx HTML. Go ahead and put that. We do an Nginx alpine. This is not as complicated as it looks. Once we look at one of the configuration files, things would be a lot easier, right? So let's do that. Let's run it, and let's see if we have it running on port 8080, right? So it's this easy to run an Angular application inside a container. Say we had a use case in which we were using Firebase with Angular, and then we had a bunch of other things that were going through it, and it required special packages to be installed from the Linux command line for them to work. Say you can take an example of image compression, right? So image compression is not something that you can do in JavaScript. It has to be something at a C or C++ level, right? So all these packages that you get on NPM that are doing image compression are actually calling those libraries behind the scenes, right? All the packages that you get, JPEG Tran and all that on Node, they're all calling the C++ libraries behind the scenes, right? So we had this a requirement in which we had special packages to be used with our application, and once we containerized that, there were no difference in environments of any of the developers, and we go ahead and deploy those as containers to the cloud or to any other environment. They're pretty much the same, and they behave the exact same way, right? So there comes a use case in which when you have fragmented environments, you have a team of 20 developers that are working. Some of them have Windows, some of them has Linux, maybe some of them are using Mac OS. And what you want to do is make sure that everyone has the correct packages and the correct environment setup. That is another case in which you use Docker containers to unify all that environment inside a Docker image, and then use that to build or deploy your application, right? So that's it for deploying or running an Angular application inside Docker. Great. So let's move forward and let's see something even better, right? Let's move on. Great. So you have this application, right? Pretty complicated application. It has a .NET Core worker. It's backed by Redis, which is being called by a Python app. And then the worker is also talking to a PostgreSQL database. And there's another app which is on Node.js, and that's talking to the Postgres database. Fairly complicated. And if I give a developer, say, I tell him, okay, we work at a services company, right? So we have a lot of turnover and a lot of teams are changing all the time. So one person exits, the other person enters, and we tell them, okay, go ahead, install .NET Core. You need Redis, you need Python, you need Postgres, and you also need Node. So he's going to say, at least give me 2 to 3 days in which I can set this entire stack up and make it working. And then even after that, he's going to come up, say, the connection string was not right. Maybe I'm missing X package. The version has changed. I don't know what's causing this. And it's going to cause further delays. And when you're working at a services company, or even if you're working at a product company, you're being paid or people are paying you for your time. And if you start wasting that time on small things, that is going to hurt a lot in terms of money, in terms of your career and all that. So how about we containerize everything? And you'll see what's the benefit of containerizing everything. So I go to the Docker, something known as a Docker Compose demo, and it has this example voting app. So this is there. This is not something that I created. That's there on the Docker samples, and it has the entire thing running. So I am going to show you, this is one container that's running. I am going to stop that, right? And now we can see that nothing is running. And I am going to do something known as docker-compose up and then detach it. You see the magic. There's Redis, there's Postgres, there's Python, there's .NET Core, and then there's Node.js. It ran everything over there. And let's see how many containers are running. There you see all the containers are running. We have an image of the app worker, which is .NET. Then we have Postgres. Then we have the command. You can see that's the Python container. Then there's another Redis container. And what was the last one? That's the Node.js one, right? So let's see if this app is even working. This would be available at port 5000 and 5858. Sorry, 5000 and 5001. So let's see if that's working. I am going to a new window, localhost. There you see, it's working. I can vote for stuff, and then I can simply go to localhost 5001, and I can see the result, right? So isn't this amazing that with a single command, you spun up 5 different things, and it took almost no time. Actually, on my machine, I have all the images. So once you run that, it download a few images, but that's only one time. So let's see this. What is this and how it happens? I'm leaving that as a question to you. That's something known as Docker Compose. And it's an entirely different topic of its own. So the idea is to have you thinking that how you can optimize and automate your stuff and save your time as much as you can, right? So a little recap before we finish off. Create consistent development environments. Accelerated developer onboarding. That's something that is the USP for me. Minimal differences between different environments. And then I have accelerated developer onboarding again because I love it. And then there's you can ship your software reliably. But there's more to it, right? How do you create these images? There's something known as a Docker file. You do a build and you create a Docker image. Then you can push and pull it onto the registry, and then you can create Docker containers out of it. If you want to learn more, there's a code along workshop post-lunch at Hall 103 where we'll get hands-on with Docker. We'll take an Angular application, we'll write the Docker file, we'll create builds from it. And there's one thing that I wanted to differentiate between what a built machine and a runtime machine is when it comes to front-end applications. So a lot of time building a front-end application, it's going to require Node.js and all that stuff. But running a front-end application doesn't require anything. It just requires a web server. So we're going to do multi-stage builds with Docker files. Post-lunch, if you've signed up for that, please join me. Prerequisites for them is you need to have Docker, Node.js, and Angular CLI installed. You can find the slides for this at ngslcon 2019-nd-docker.mohawk.com. Thank you for everything, the sponsors, the organizers. You can connect with me on Twitter and GitHub. If you have any questions, I'd be there in the hall. Thank you.